couple tricks that you need to know here, which some students are bringing up in earlier projects. So if I multiply 1001 times 1001 in Python, let's just clear this off and clear this off. Well, you use this same notebook, it'll be fine. So I'm going to just multiply a times a, so I get this big number. Okay, that's 1001 times 1001. Now, if I make a large integer and multiply it, this is 10 to the 100 plus 1. It calculates it as 10 to the 100 is 1 followed by 99 zeros followed by a 1. If I multiply two of them together, I get this ridiculous long number ending in 1, and there's going to be some non-zero, a 2 in the middle. Okay, so it counted correctly. So this number, which is now 200 digits long, it got exactly right. So Python is infinitely accurate for integer arithmetic. You don't need a special precision library or anything. As long as you're using integers, it runs at 100% accuracy no matter how long the number is. But the square root function is not that good. So if I calculate that number, 10 to the 100 plus 1 squared, and then I take the square root of it, let's see what happens. All right. The square root is 1 to the 100, which is wrong. It's 10 to the 100 plus 1, and not just 10 to the 100. It didn't keep enough places to get it accurate. So that's a problem. All right, so what you have to do to fix that is use the decimal library. This is what you do instead. You import the decimal library, and now you can specify the precision. So I can say I want 200 digits of precision. And now when I do the square root of that number, it will be better. And see, now I get the right number. 1 followed by 99 or 100 zeros and then 1. So it works. All right. So that's how you handle large numbers. So now, if I want to find the factors of this number, we're going to do it. Now you can tell this is a number where two factors are similar. It has this pattern of a lot of zeros and a little bit in the middle. So what I'm going to do is find the square root of that number. By using decimal and high precision, I can get the square root of that number with reasonable precision. So that's where you want to start looking. So the square root of that number is this number, 1, a bunch of zeros, and then 83 or 84. All right? And it's not a perfect square. It's the product of two different prime numbers, so the square root is not an integer. So that just tells you where you're going to need to start looking for factors. So here's how you test for candidate factors. You found this number, 83 plus a fraction. So you start at 83, and then you go down from 83. One of the factors has to be bigger than 83 and one less than 83. That's P and Q. P is the smaller one. So to find P, I start at the square root and go down. And I will eventually, somewhere down here, is the factor. Now, if it's really randomly chosen, then it might take way too many guesses. But in fact, it's not that randomly chosen. This is a multiplication of two numbers that are similar and near the square root. So here, if I just do 50 guesses, so I'm printing the guess for P, and then n% P, which is going to be 0 if it's the prime factor. You can see I'm getting weird numbers, and there I got a 0. So now I found P. I found the number that it's 1 followed by a lot of zeros and then 39. Now, once you find P, you have to find Q, and that involves a little bit of trickery too. So if I go down here, all right, so I found P and I have N. Now you might think I could just take Q as N over P, but if you do that, it will turn into a floating point number and it won't be accurate. You have to use 2 slashes for integer division, which is what you need. And now it works. Now you get Q, and you can test it by printing P times Q and N minus P times Q, and it's 0. Now, if I had only 1 slash here, it wouldn't work. Now I would get, well, I wouldn't be able to see the answer. It looks like it somehow did work in this case, but in general, it doesn't work for other kinds. The 2 slashes are what you use for integer division. And you see, I'm not really being able to see it very well. It turned them into floating point numbers. And I think in this case, the floating point numbers were accurate enough, but for a lot of the problems you're doing, they aren't. So that trick of the 2 slashes for integer division is very good. And so there are a couple of challenges here for you to factor numbers using techniques like this. So that's all there is to that one.